Alright guys, so what I'm going to do right now is go over our notes for isosceles and equilateral triangles. Specifically, we're going to take a closer look at them because they have some special characteristics that will help us solve things as we go. Alright, so first of all, let's go ahead and take a look at isosceles triangles. There are two congruent sides and we call those legs. Again, if you remember in our one lesson, I told you that isosceles means isosceles. And remember, iso means same and sceles meant legs. Okay, so the angle where the legs intersect. So first of all, let's go ahead and mark the legs. That is going to be segment AB and segment BC. Those are our legs. Now looking next, the angle where the legs intersect is called the vertex angle. And that is going to be right here at angle B or angle 1, whichever one you want to look at. It's going to be the same. Okay, so the side opposite the vertex angle is called the base. And that's going to be segment AC right here. And then last, we see that it says the angles along the base are called base angles. So that's going to be 2 and 3. Right? So one reason these very specific properties will help us is that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So what that tells us is that because segment AB and segment BC are congruent, then angles 2 and 3 are also congruent. So if the isosceles triangle theorem is true, then the opposite or the converse of the isosceles triangle theorem is true. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So what that means, again, is if angle 2 and angle 3 are congruent, then the sides opposite are the ones across from them. So those will also be congruent. So again, if angle BAC is congruent to angle BCA, then segment AB is congruent to segment BC. And that is one way you can prove that triangles are isosceles. All right, we're going to pause here and we're going to make sure you get this part of your notes copied. So now that we reviewed the properties of isosceles triangles, we're going to put that information into practice. So let's take a look here at number 1. They tell me that JK and KL are congruent. And again, they do that by giving us the little tick marks right here. So as a reminder, if the two sides are congruent, then the sides opposite, or the angles opposite the sides, are also congruent. So that means angle J and angle L are congruent. So that means angle J is 68 degrees, since angle L is 68 degrees. And then for angle K, we're going to use the interior angles of a triangle. We have the measure of angle K plus the two other angles, so 2 times 68, because they're both 68 degrees, is equal to 180. And then all we have to do is subtract 2 times 68 from 180. So our next line would be the measure of angle K times 68. There's the calculator, and we get 44. Up next, problem number 2. They have given me some information here. They tell me that segment CD is congruent to segment DE, and again, that's because of the tick marks on the segment sides. So what that tells me again is if those two sides are congruent, then the angles opposite the sides are also congruent. So that means angle C and angle E are going to be congruent. So there's two of them. We know we're going to end up dividing whatever we have from 180 by 2. So what I would do here is I would say that the measure of angle D plus measure of angle C plus the measure of angle E is equal to 180 degrees. All right, so we don't know what angle C and angle E are. We just know that they are the same. So what we can say is that 106 plus 2 times the unknown measure, so we're just going to say x here, is equal to 180. Okay, so we're saying the measure of angle C is equal to x. And since these are the same, we can have 2 of them. And then we're going to subtract 180 or 106 from 180. So let's go ahead and do that. We get 74. So we know that 2x equals 74. And 74 divided by 2 is 37. So each of these is a 37-degree angle. All right, now looking at number 3, we are given the two angles, angle X and angle Z, are congruent because they are both 77 degrees. And remember, the converse of the triangle or isosceles triangle theorem is that if the angles, the base angles, are congruent, then that means the opposite sides are congruent. So that means we can mark XY and YZ congruent. And then we also have enough information to solve for angle Y. So first of all, the measure of YZ, the length of YZ, is going to be pretty simple as it is congruent to XY. So YZ is 12 centimeters. And in this instance, they do give you units, so you need to give me units back. And then to solve for Y, we know that the measure of angle X plus the measure of angle Z plus the measure of angle Y is equal to 180. We know that measures of angles X and Z are both 77. So there's 2 of them. So 2 times 77 plus the measure of angle Y is equal to 180 degrees. And then if I subtract the 2 times 77 from both sides, so I'm going to end up with measure of angle Y equal to 180 minus the two 77-degree angles, and I get 26 degrees. We're going to pause here for a moment, and I want to make sure that you get this part copied into your notes now. All right, so for numbers 4 through 7, they want us to use the information that we have been given to find the missing variables. All right, so on number 4, we're going to use the isosceles triangle theorem with the angles. So we're going to see again that this angle right here is going to be congruent to the angle opposite this side. Again, because both of these sides are marked as congruent by the tick marks. So in order to solve for x here, I am simply going to set these two expressions that are the measures of these angles equal to each other. So that means I'm going to put 5x plus 9 is equal to 8x minus 30. And then I want to subtract 5x from both sides. And that's going to leave me with 9 is equal to 3x minus 30. And then I'm going to go ahead and add 30 to both sides. So that will give me 39 is equal to 3x. And then what I'm going to do is divide both sides by 3. And that gives us an answer of x is equal to 13. Now looking here at number 5, we have the same thing. We can see that we have congruent sides as indicated by the tick marks. So what, again, that means is the angles that are opposite those sides are congruent to each other. So we can mark those two angles congruent, right? And then what we're going to do is set these two expressions equal to each other. So we're going to say that, I'm going to say 9x minus 33 equal to 4x plus 7. And then what I want to do is I want to go ahead and add 33 to each side, which will give me 9x is equal to 4x plus 40. And then I'm going to subtract 4x from both sides. Now, could I technically do this without using the formula tool? Yes. However, I do want to keep getting used to it because it looks better when we start looking at other kinds of math. For example, anytime we need to use math symbols, it's usually better to use the formula tools or to write it by hand. And because I would like for this to be legible for everyone, it is better if I go ahead and type it. So now I'm going to divide both sides by 5. So that gives me 5x over 5 is equal to 40 divided by 5. Okay, and then once we do that, divide both sides by 5, we are given the answer that x is equal to 8. Right? Number 6 and 7, again, we're going to use the converse. So for number 6, they give us that these angles are congruent. So what that indicates again is that the sides opposite the angles are also congruent, which means I can set these expressions equal to each other and solve for x that way. So I'm going to say 23x minus 17 is equal to 15x plus 7. I'm going to go ahead and add the 17 to both sides. And yours does not have to line up perfectly. This is just something that I prefer. So then we have 23x is equal to 15x plus 24. Now I'm going to subtract 15x from each side, and that will leave me with 8x equal to 24. And then of course after that we're going to divide both sides by 8. That would have 8x over 8 equals 24 over 8. And that's going to leave us with a final answer of x equals 3. All right, number 7. We're again given that two base angles are congruent. Right here. They're told that they are 74 degrees. So again, that indicates the sides that are opposite are also congruent. So we mark them congruent, which again means that I can set these two expressions equal to each other and then solve for x. All right, so I have 9x minus 73 is equal to 3x plus 23. I'm going to go ahead and add 73 to both sides, again, simply because I like having my positive x on the left. There's no other real reason to do that. I am only making it line up because that is what works for me. Okay, so that tells me we now have 9x is equal to 3x plus 96. We're going to subtract 3x from each side, which will leave me with 6x is equal to 96. We're going to divide both sides by 6, which gives us x equals 6. So what I want you to do is go ahead and take a moment, pause right here, make sure you have these 4 problems copied into your notes. All right, for numbers 8, 9, and 10, we are going to want to draw a picture. Luckily, Cami has a tool for us. We can just go to Insert Triangle. I'm going to make it black. And I want to make the lines about 2. Okay, so I'm just going to go to Triangle. And I can make it, it's Isosceles, because you can see it's telling me my congruent markings. If you do it right, you can actually make them equilateral, but it does take a little effort. So what we want is an isosceles triangle though. And I'm going to move it up a little bit. And then it tells me it's RST, where RT and ST are congruent. So what that means is I'm going to have my text box, and I'm going to say that this is R, and this is S, because RT and ST must share a point. So therefore, T must be the vertex angle. And let me go ahead and relocate all this again. There we go. And so again, the next thing I'm going to do is go ahead and mark the two sides it tells me are congruent, RT and ST. I'm going to go ahead and mark them congruent. And again, because RT is congruent to ST, that means angle S is congruent to angle R. Again, because they are opposite the congruent sides. So that gives us a lot of the information that we're going to need for this problem. So measure of angle R and measure of angle S will give us the information to solve for X. And then we will use X to determine the value of what is the measure of angle R and S, and then what is the measure of angle T. Now remember, we only have to do R or S once we have solved for X, because they are congruent. I know that because RT is congruent to ST, that the measure of angle R is equal to the measure of angle S. So I'm going to set those two expressions, 9x plus 2, equal to 13x minus 8. I'm going to add 18 to both sides, and that's going to leave me with an x plus 20. And now from here, I am going to subtract 9x from each side, which will leave me with 20 equal to 4x. Okay, I'm going to have to continue in a second column. That's okay. I'm going to divide both sides by 4. So 20 divided by 4, or x divided by 4. And that will give me a final answer of 5 is equal to x. So the first thing I'm going to do is go ahead and put 5 over here. And now that I've solved for x, I can use that information to find R and S and T. Again, I'm only going to do R or S, and then I'll do T. So I'm going to do the measure of angle R, simply because 9 is smaller than 13, is equal to times 5 plus 2. 9 plus 5 is 45. So the measure of angle R is going to be 47 degrees. And since R and S are congruent, that is going to be 47. Now for the angle T, we could use 180 minus the sum of 47 and 47. Or we could, in the spirit of the assignment, go ahead and just plug 5 into the expression given. So that's what I'm going to do in this case. So the measure of angle T is going to be equal to 17 times 5 plus 1, and we get 86. And if we want to check our work, we can add the 3 angles together. Oops, 86. We get 180. All right, same process for number 9. First thing we're going to do is draw the triangle. Again, they give us an equal or an isosceles triangle by default. And then we're going to label it. So it says angle D is equal to or congruent to angle E. So that's the ones I want to be my base angles. So I'm going to put D here. And I'm going to put E over on this end, which means the vertex angle is going to be F. Okay. Again, since they are telling me that angle D and angle E are congruent, that means the sides opposite those angles, so FE and DF, are congruent. So that is some information we want to put down. So that's some information we now have. So Now we have enough information to solve for x and then find the length of each side. So we're going to set df equal to ef. So now we're going to have 4x minus 8 equal to 7x minus 35. We'll go ahead and add 35 to both sides, which will give us 4x plus 27 equals 7x. Okay, so now I want to subtract 4x from each side, and that will leave us with 27 is 3x. And then we're going to want to divide both sides by x over 3, which would give us a final answer of x is equal to 9. It's 27 divided by 3. Now we need to find the length of DE, EF, and DF. But again, we're just going to do that by substituting in the value of x. So DE is equal to 9 plus 4, 13. EF is equal to 4 times 9 minus 8. It's 36 minus 8. And we get 28. And then finally we have DF, which is 7 times 9, 35. And again, we get 28 because EF and DF were congruent. All right, stop here, take a moment, and make sure that you have these copied into your notes. All right, the last thing we're going to talk about in this set of notes is equilateral triangles and their special properties. So a triangle is equilateral if and only if it is equiangular. So what that means is every time you have an equilateral triangle, you also have an equiangular triangle. So that means the angles are also congruent. So mathematically what they're saying here is that if measure of angle A equals the measure of angle B, which equals the measure of angle C, then mathematically AB equals B equals AC. And then conversely, the same is true. So if all three sides are congruent, then the measures of each angle is also congruent. So the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C. When it's equiangular, remember the measure is always, redo that, always measures 60 degrees. Let's use this information. So we can see that on number 11, angle A is 60 degrees, angle B is 60 degrees. If angle A and angle B are both 60 degrees, then of course angle C must be 60 degrees. That is the only way that will work out. So we're going to say that the measure of angle C is 60 degrees. And then if all three angles are congruent, then that means all three sides are congruent. So if AB is 9 feet, then it stands to reason that BC is 9 feet and AC is 9 feet. We can use that same information over here with number 12 with triangle JKL. All three sides are marked congruent, so that means all three sides are 24 centimeters. But remember, if it's equilateral, then it must also be equiangular. Okay? So if JK, KL, and JL are all congruent, then angle J, angle K, and angle L are all congruent, which means the measure of each of them is, in fact, 60 degrees. So knowing this information means that we can save ourselves some time when it comes to solving for the third angle in a triangle, or even when it comes to solving algebra problems with this information, as we're about to do in the final problem on this set of notes, which is number 13. So number 13 says, if triangle PQR is an equilateral triangle, solve for x and y. So first off, again, if it's an equilateral triangle, that means all three sides are congruent and all three angles are congruent, which means each angle is going to be equal to 60 degrees. So they give me measure of angle R. So we're going to do that first. I'm going to solve for x first. It doesn't really matter which order I do it in, but the measure of angle R is equal to 7x minus 3. And because this is an equilateral triangle, we also know that the measure of angle R is 60 degrees. So now I can set 60 equal to 7x minus 3. And add 3 to both sides, which will give me that 63 is equal to 7x. And that gives us x equals 9. So how to solve for y? Well, if this is an equilateral triangle, then we know that each of the sides are congruent. So that tells us that PQ is equal to QR, which is equal to PR. And then you're going to choose any two sides to set equal to each other. So I'm going to select PR and QR, and I'm going to say 11y minus 23 is equal to 9y plus 1. And the first thing I want to do is I want to go ahead and add 23 to both sides, which will give me 11y equals 9y plus 24. I'm going to subtract 9y from both sides, and that's going to give me 2y equals 24. Divide both sides by 2, so we get 2y divided by 2 equals 24 divided by 2, which gives me a final answer of y equals 12. So those are how we use the properties of an isosceles triangle and those of an equilateral triangle to find different angle measures or even different side measures.